Hi friends, this is Ashish from developerhut.net. Welcome to the next topic of Java 8 feature series. So in our earlier video sessions, we saw what is the function interfaces and how we can use the Lambda expression in a Java 8. So if you are not aware about these two topics, so you can go through the video link which is right now appearing at your top right corner. You can get a good understanding of these two topics and come back to this video later. So let's move ahead with our current topic, which is newly added functional interfaces and their respective Lambda usage. So in Java 8 there are a lot of functional interfaces added. So out of those there are four very basic interface which I am going to cover in this video session. So the first interface is an consumer interface, then next is the function interface, the predicate interface, and last is the supply interface. There are also a dozens of function interfaces added along with these four interfaces. However, all the other interfaces are merely an advanced version of all these four interfaces. So let's start using all these function interfaces. So the first interface is an consumer interface. The consumer interface used whenever you want to perform certain operation on your object. However, you do not want any alteration in that particular object state. So this consumer interface accepts one single argument and does not return any value. It has a one method which is accept, and of course as I mentioned, it takes one argument of type T, whatever the consumer defined, and it has a void return type. So let's see the actual use case of the consumer interface. So let's say I have an array list of users which contains a name of users, and what I want is I want to get all the elements of this array list. So the array list has a very interesting method which is for each. So this for each method takes an implementation of an consumer interface. So we will see the two versions of all the interfaces. So first is the anonymous class version, and then we will move ahead with the Lambda version of it. So let's proceed ahead for the anonymous class. So I will create a anonymous class of consumer interface, right? So as my array list is of type string, right? So I will add a string as for my consumer interface, and let's override or implement our method which is an accept method, right? So accept method we will add it over here. So instead of T, what I will say name, right? And what I will do, I will just sys out the element, what are the element which come inside this method. So I will say name, and I will just print it out, okay, the name. So now if you run this Java program, it will print all the elements inside this array list. So I will say simply run. Now here you can see it prints all the elements inside the array list, right? So for each internally calls the accept method of an consumer interface, and it will print all the elements. What are the operation that, what are the business logic that you added inside the accept, it will do or perform that operation. So this is the anonymous class version. Now let's see the Lambda version of it. So what I will do, I will simply copy this method and I will update this. I say v1, and I don't require the anonymous class version now, right? So I'll just remove this. So as you're aware, in Lambda, right, there are three major parts. So one is the in arguments, so in our case which is the name, right, then the arrow operator, and last is the expression block which contains the actual business logic. So let's add the in argument first. So in our case I will just say a name, right, then the arrow operator and the expression block, right? So in an expression block we will just simply add our system.out.println, and to differentiate between these two methods I will say with lambda, Okay, now let's try to run this program again, and I will say run as a Java application. And yeah, here you see, so it says with Lambda and name is the output, right? So this is how the consumer interface will work. So as I mentioned, the consumer interface works in those scenarios where you do not want it to perform any alteration of your object, right? So we don't want any alteration, so we just want to sys out or get some values from the object, right? So this is the use case for the consumer interface. Now let's move to the next interface. So our next interface is an function interface. So function interface used in those cases where you want to perform certain operation on an object and you want to alter the state of the object, or you want certain new object on uh, whatever the business logic that you perform on your input object, right? So the function interface accept one argument and it returns one argument, right? So it has a one method which is apply, which will take an argument of type t and returns an argument of type r. So let's see the use case of the function interface. So we will use our same example, array list of our names. Now what I want is, I want all my usernames which is resides in this array list. I want all these usernames to be converted to the uppercase. Okay, so let's use our array list. So user list has one method which is stream. This is a new method which is added in Java 8, and if you not don't understand this stream method, so don't worry about it. So we will be anyway going to cover the stream methods and other related method in our upcoming video session, which is stream CPI. Okay, so basically the stream method will convert all the user list in a stream of objects. Okay, so we already converted it to stream of objects, and this stream method has one more method which is map. Okay, so this map method will take an implementation of a function interface, and whatever the values written by the function interface, it will be collected into the map. Okay, so let's see the first version of it, which is anonymous class version. So I will create one anonymous class, so new function, which is of, in our case, which is of type string, right? So my input is of type string because my array list is of type string, and what I want is the, again, my output will be of type string only because I just wanted all my elements to be converted to the uppercase, right? So let's override or implement a method. So I will say implement method, which is apply in our case, which will take argument of type t and return argument of type r, right? So in our case, what I will do, I will say here, say original name, right? So original name, and what I will do, I will just convert here original name dot to uppercase, right? So if you see here carefully, so this apply method takes an argument of original name, right, and it will just convert, it will return the uppercase version. So this map method will return a stream of string, right? So let's collect this stream of string. So select, press Ctrl 1 and extract to local variable. Okay, so I will just simply say the map. Okay, so I have a map, and let's print this element with our consumer version, right? So consumer lambda version. So I will say map for each, right? And what I have here is I have a updated name, so I will say updated name, the arrow operator, and the sysout, the expression block, right? So I will add, I will say updated name, and I will just say the updated name, right? Now let's try to run this program. So I will say run as a Java application, and let's see, yeah, here you can see, so all my usernames converted to the uppercase now, right? So this is the function interface. So map will internally call the apply method of the function interface, and whatever written by the apply method is collected in the map. Okay, so this is an anonymous class version. Let's see the lambda version of it. So I will just simply copy this again. I will rename it. I will say let's v3, right? And I don't need this anonymous class now, right? So in lambda version, okay, how we can use a lambda version here? So it's simple. So we are providing the original name, right? So in our this case it will be original name, right, the arrow operator and the expression block, and inside expression block we will just simply return original name, right, dot to uppercase, right. So it will just return, and what I will do, I will just update this. We will same collect in a map, and I will say with lambda, so that we can differentiate this both method. So I will just right click and will run as a Java application. So if you run, you can see with lambda the updated name is this. So this is the lambda version of the function interface. Now let's move ahead with the our third interface. So our third interface is an function interface. Uh, So our third interface is an predicate interface. So predicate interface is basically also called as a boolean value function interface, because this method returns the boolean value, and it will take one argument, and it will return the boolean value associated whatever or according to your business logic. So this predicate interface mostly used where you want to perform certain operation on your object, and you want to check certain conditions. So let's see one particular use case of the predicate interface. So what I want is, now in our case I have again a list of usernames, right, and what I want is that I want all the users who has letter A in it, right, small letter A. Okay, so let's convert first. What we need to do is we need to convert our array list into a stream of objects. So I converted it, and the stream has another method which is filter. Okay, so this filter method takes an argument of implementation of an predicate interface. Okay, so let's see the first anonymous class version. So what I will do is I will say new predicate, right. So my predicate will be of course of type string, right. So string, and what I will do is I will implement a method which is, in our case it is a test method. So predicate has a test method, right. So I will just remove this part, and I will say it's a name to get a more clarity. And what I will do is I will return name if my name contains and letter A, then it will return true, right. So if name contains A, it will return true, else it will return a false. Okay, so this filter method also return a stream of a string. So let's collect the stream of a string in a local variable. So I will say it's a filter, right, and what I will do is I will just simply for each, so that we can check whether we got the proper result or not, right. So in our case it's I will see name, right, the arrow operator and the expression block, and inside expression block I will say sysout and name, and I will just simply say name, right. So if you run this program, let's see whether we get objects with letter A or not, right. So here you can see, so we got all those names who has letter A in it, right. So basically this filter method called the test method of a predicate interface, right, and it will collect all those objects where the test result is true. Okay, so this is the anonymous class version. Let's see the lambda version of it. So I will just again copy this, I will rename it to v5, and I don't require this now, right. So in lambda version again we have a name, Okay, you don't have to give the curly braces all the time, right? So likewise we give it over here, right? So you don't require all the time, so you can also do this and it will work, right? And the expression block, where what I will do is I will return if name dot contains letter A, right? And the semicolon, right? And again we will collect it to the filter, and I will say here with lambda, right? And I will just save, and I will just quickly run this program. So this is a lambda version of it, and here you can see, so it will print the with lambda and the name, right? So this is the predicate interface. Now let's move to the last interface. So our last interface is an supply interface. So supply interface do not accept any argument. However, it returns the result of type T. We can say supplier is an exactly opposite version of an consumer interface, where you can see consumer interface accept a single argument and it returns no result. However, supplier do not accept any argument. However, it will result is written. There is a result which will return from its method. So let's see the example or use case of supplier. So let's create a supplier first. So I will say supplier, right? So supplier of type string. Okay, I will say supplier, and I will say here I will say new supplier, the anonymous class version, right? So supplier has an method, right? So supplier has a method which is get. So let's implement that method. So I will say get method, and what I will do, I will just simply return the value, any value that what I want. So it is I say Adam, right? And now let's sys out, and I will say supplier, right? So supplier dot get, okay, and I will here say the get name, right? And let's try to run this program. So I will just right click, I will say run as a Java application, and here you can see, so we got a name, right? So this is the anonymous class version of the supply. Let's see the lambda version of it. So I will just simply copy this and I will rename it. So I say v7, and so in this case this is a lambda version, right? So we do not require this. So I will just simply remove this, and here now we do not have any in arguments, right? So, however, we have out arguments, so we don't require it. So you can keep this blank, then the arrow operator, and here you can just simply say return, right? Return, I will just simply say here, I will take a different name, so I will say Bob, okay, and I will update this. So with lambda, I will just save it out. I will right click and let's run this Java program, and yeah, here you can see, so we have a lambda version, right? So this is a supply interface. So if you don't understand the use case of the supplier, it's perfectly okay. So anyway, I am going to cover the supply interface in our next upcoming video, which is a streams API. Supply is also very heavily used. So all these interfaces are of course very heavily used in collection and the streams API. So anyway, we are going to cover. So these are all the four functional interfaces. For the other interfaces, you can go through the Java doc and find out what all the other interfaces are. There are a lot of other interfaces along with this, and you can use those interfaces according to your developmental needs. Okay, so I hope you understood the concept of all these four function interfaces and their respective lambda usage. So if you think this information is valuable, please do like this video, share this video with others, and please subscribe to my channel. Thank you.